Hello, I'm Sharleen, a technical associate at Codezilla community. So I'll be talking about introduction to deep learning today. It is a subset of machine learning. So what is deep learning? Deep learning uses an algorithm called neural networks, which are loosely inspired by biological neural networks in human brains. Neurons, also sometimes called nodes, are the basic unit of neural networks. Deep learning is a special type of machine learning that can solve more complex problems, but it requires much more data than traditional machine learning. It requires images and text as it is considered as the best input. So how does it work? Here, you have an access to a data set where you know the size and the price of the houses. As you can see, a straight line can be drawn through the data points, showing that as size of the house increases, the price of the house also increases. This red line is an example of prediction from a simple model. The neural network that would accomplish this can be drawn like this, where the size is passed as the input to a neuron that calculates the red line and outputs the price of the house. Suppose we have gained access to more information. On top of the size of the house, you also know the number of bedrooms. So one of the things that affects the price of the house is the family size. The first neuron helps us to find the family size. There's another feature, which is the zip code. It tells us about the walkability. So the second neuron estimates the walkability. And then the zip code as well as the wealth in some countries tells us the quality of the school. Finally, we need to add one more neuron which takes these three as the input and outputs the price of the house. And that's the end of our neural network. To train a neural network, all you need is the training data to input. We just saw an example of a small neural network, but in reality, neural networks are much larger with thousands of neurons. This is the point where we start using the term deep learning. By stacking a large number of neurons, which can compute large functions, that gives you very accurate mappings from the input to the output. So when should we choose deep learning as the solution? Deep learning can outperform other techniques if the data size is large. But with a smaller data set, traditional machine learning algorithms are preferable. Because of the complexity, deep learning techniques require powerful computers to train in reasonable time. When there is a lack of knowledge, deep learning outshines the traditional machine learning as the neural networks figure them out for you. And deep learning really shines when it comes to complex problems such as computer vision and natural language processing. Okay, so now let's focus on images and how they are used in computer vision applications. So what is computer vision? The goal of computer vision is to help the computers see and understand the content of digital images. Computer vision is necessary to enable, for example, self-driving cars. Manufacturers such as Tesla, BMW, Volvo, and Audi use multiple cameras to acquire images from the environment. To understand how it works, we need to find out what image data looks like. An image data is made up of pixels. These pixels contain information about color and intensity. On the slide, you can see a grayscale pixelated image. Each pixel's intensity can be represented by a number between 0 and 255. But what about colored images? A colored image is generally stored in the RGB system. RGB stands for red, green, and blue. Each image can be thought of as being represented by 3 matrices, one for each color channel. This means you need 3 times the amount of data to store a colored image compared to a grayscale image. So let's take an example. How can we find out the identity of a person using neural network? So to find out the identity of a person, all you need to do is give it a lot of images of faces, the features, as well as the correct identity, the labels, and during training, the learning algorithm will figure out by itself what each of the neurons in the middle should be computing. Some of the applications of computer vision are facial recognition software, self-driving cars, manufacturing production line, automatic detection of tumors in CT scans, augmented reality, and much more. Okay, now let's focus on text data. Natural language processing, or NLP, is the ability of the computer to understand the meaning of human language. So we are using a technique to identify and categorize the named entities under predefined classes. Here, the predefined classes are location, person, term, date, condition, process, and people. So what do we do when our data is text? A simple option is to count the number of times important word appears in each piece of text. This technique is called bag of words. Bag of words is a useful technique that is commonly used in NLP. But bag of words has its own limitation. The word counts don't help us consider synonyms. Example here, happy, exhilarated, cheerful, ecstatic, elated, and much more. They all mean the same things. Ideally, we would like to group these as a single feature, but bag of words limits us from doing it. One solution to these problems is word embeddings. It is a special way of creating features that groups data together. Word embeddings has another interesting property. They have a mathematical representation of words. Here, the man points to the woman the same way as the king points to the queen. This helps us to group together similar words. So after mapping words or sentences with the bag of words technique or using word embeddings, we can pass them to a neural network, which can help us to translate the input sentence, which is clearly in a different language, to an output sentence. Here it is English. So some of the applications of natural language processing are search, autocorrect and autocomplete, social media monitoring, language translation, chatbots, personal assistant, sentiment analysis, and much more. That's all for today. Thank you so much. For more interesting content, you can connect with us on our various social media platforms. Thank you.